Hi, I'm Dennis Stevens, and I have over 20 years of experience as a database developer and a data analyst. Now, the term data science and data analysts are all over any discussion these days of technology and careers in technology. So, in this video, I will take an actual scenario with actual data, and I will show you how I will prepare that data so that I can perform analysis on it, and then look at some of the insights that we can derive from that. In this case, the data will be a publicly available file from the city of Los Angeles, California, about crime statistics in the city of Los Angeles. This file covers, I believe it's about 10 years. We'll determine that when we look at it later in this video. The file is a CSV, or comma separated value file, which means you can pretty much open it in any text editor, Notepad, Word, Excel spreadsheets. Although in this case, the file is exceptionally large. Well, fairly large. It's about 2 million rows worth of data. And I'll put a picture of it up here on the screen, and you'll see why it's called comma separated value. The top row is a description of the data directly beneath it. So you see date occurred, date reported, and then a comma between those terms. And right below it, you'll see a date, and it looks like there's kind of a timestamp and a comma, and then another value. So we know that this file, as large as it is simply text data being separated by commas. Now, the fact that it's 2 million rows presents a couple challenges. Excel cannot open a 2 million row file. It can certainly open comma separated value files. Those often work very well in Excel. And Excel is a great tool for data analysis. But a lot of tools, in fact, I'd say all the tools, come with their pros and cons. Now, I have been asked in job interviews, what's the best tool for data analysis? And the answer is always the tool that the data analyst knows best and can do the job. A lot of people are real Excel masters. Although in the case of this file, it's a little big to be opened as one spreadsheet, although you could split that data into multiple spreadsheets, and then you could combine them. I am a database person. I started with an old piece of software called Sybase that was way back in the 90s, which uses a flavor of SQL called Transact SQL. If you're familiar with data and databases, you'll know that SQL is SQL, Structured Query Language. That is the language of most databases, certainly of what's called SQL-compliant databases, which a lot of database systems are that. Two of the biggest, for example, are Microsoft SQL Server, which is based off the old Sybase that I used back in the day, and Oracle is another big player in the database game. Now, it so happens that Microsoft gives a free developer edition of SQL Server, so I'm going to use that. First, because a 2 million row table in SQL Server is should not be a problem. Also, I have spent most of those 20 years writing SQL statements. So it's something I'm very comfortable using, and I know different functions, a different way to use that in an effective way. And then that's just me. So that's part of being a data analyst. If you are a data analyst now, or perhaps you are looking to enter that field as an employee of a different company, they may provide you with different tools they want you to use. Keep in mind that often a data analyst has to present data to other people who may not be technical people. They may be in marketing, sales, HR, upper management. These people aren't writing SQL statements, which is why there's many other tools. For example, SQL Server Reporting Service is a tool that's kind of a companion to SQL Server, which creates nicely formatted reports that you can share to people in a nice graphic interface that anyone can understand. There's also from Microsoft Power BI. BI, I believe, is business intelligence. From what I've been told, that's supposed to replace SQL Server reporting services. And in another video, I will maybe hook up Power BI to the data that we're going to be looking at in this video. In this one, this video, I will try to keep relatively short and straightforward of getting that data into a usable format, and then doing a couple basic queries in the database in SQL. Now, as a data analyst, the first thing you want to do is know as much as possible about the source of that data, because all your reports and your conclusions and your insights are kind of based on that data. Where did it come from? What does it mean? So in this case, we definitely have some challenges. The website that this comes from, it's from a City of Los Angeles website, states that a lot of the data is simply manually entered into the CSV file. It comes from different sources. Also note, this is crime data, and it's one row per incident of crime, per reported crime. They're not even arrest records. This file doesn't tell us if anyone was arrested for these crimes or what the outcome of the report of the crime was. The data is also anonymized. There's nothing to tell us who the person or persons involved were, which of course is good. And data, anonymity and personal privacy, of course, are an extremely important issue. Healthcare data, of course, often concerns itself with the privacy of individuals. But as we can see, in the case of, for example, crime data, it's not healthcare data, but I think it's pretty important that we don't invade anyone's privacy. But fortunately, the people who compiled the data, who created the CSV file, have already done that for us, so we don't really have to worry about it. We will see that some of the data will appear to be missing or incorrect. And in this case, we don't have any way to contact the people who compiled it to see if they can provide missing or correct data. We kind of have to take it the way it is. And but that is good for the purposes of this video, because that's something that happens. And we'll talk about different ways that can be handled. Okay, so let's get to it. Okay, so I'm using SQL Server's built-in function to import flat files, which is what a CSV file counts as. Now, it's a pretty nice interface. You see, you just navigate here, click Next, I browse to the file. I have to find it. Now you see, click on it, that's the file. Click that. It's going to import into it's going to create a table with the same name as the file and import into it. Here, I'm going to preview the data. SQL Server is reading the first couple rows of the file. It's not going to read the entire file. And it's just going to show this is what it thinks the data should look like, which is basically correct. These are all the columns, and this is all the data. It seems to have figured that out correctly, so I click Next. Now here, SQL Server is kind of taking a guess. It's taken a sample of the file and the column names and made kind of a guess based on a sample of what the data type should be for each column. So we have dates, we have times, we have nvarchar, or text field, we have a number of fields, and it looks okay. So I'm like, let's go ahead, let's just try this. And it's going to do its thing. It's going to work for a while. We're going to... and sometimes it's worthwhile to just, if it looks okay in those beginning steps earlier in this video, give it a shot. This will fail in a second, which it did. So I click to see what's the error. It looks like... oh, we had a null value and we had a column that doesn't allow nulls. So I'm going to fix it. I'm going to allow nulls because I just want the data in a table. I just want that raw data from the CSV file in that table. So I'm going to allow nulls. I'm going to let it run for a while. Run. I might cut out some couple seconds of this. Although if you had a job as a data analyst and you were loading this data, this is what it would be like. You would be sitting here saying, okay, run, come on. I really want this to work. I don't want to hear the errors. Oh, now I got an error. All right, now what's going on? Oh, another field that doesn't allow nulls. You know what I'm going to do? I'm going to say, look, there's probably a lot of other null value here and there. So I'm going to say I'm going to allow nulls in everything because my feeling is just get that data in the table. Because I know, if I'm a SQL guy, get it into SQL, get it into the SQL Server table, and then I can handle nulls, I can handle bad data, I can do all sorts of things. Once I have the data in a table. The 2 million row CSV file. Oh geez, oh boy, we got another one. Let's see what this says. Okay, so we have here a given value 998 of type string cannot be converted to nvarchar. String or binary data would be truncated in table. Column crime code 3. It's trying to put 3 characters in crime code 3, but SQL Server thought it should only have 1. So it's another case where SQL Server guessed that it would you only need 1 character, but there's a 3 character buried in the 2 million rows. because it looks like it finished. Okay, so this message, up to 11 cells of data from dropped to insert from the following columns, dr underscore number. I don't really know what dr underscore number means, and I don't think it's important for how I want to analyze this. So if you think about, and this is another kind of issue when you're looking at different data sources, what data are you looking for, or have you been tasked to look for? In this case, I'm assuming we want what the crime was, the time, the date, and the place. That's the main piece of information we want. There may be, if there's other information in the file that is useful, that's great. But dr number, I don't know what that means. I don't think it's important for what I'm trying to do, so I'm not going to spend time troubleshooting that. I have the original file. Keep that in mind. You want to keep, I'll keep that original CSV file around if I ever need to look something up or see what the original data said. But I'm going to say that the data has been inserted, a table has been created, and that's our first task here has been accomplished. So now let's do some actual analysis. So now we see we've imported our data into a table which has the same name as the file. It's all there, so that's really great. We can start doing some real work here. And again, as I mentioned, we've got columns that we don't particularly need for what we want to do. One thing, let's find out the dates that we actually have. So we see the date is up to October 13th, 2018. Let's get the beginning of the date. I'm going to put the min up on top. It seems kind of more intuitive for me. So it's January 1st, 2010 to October 13th, 2018. That's the range of data we have. Okay, so I wanted to see how much crime there is for each area. And now let's order by the count, because we want to see who has the biggest total number of crimes. Let's make that descending. So 77th Street looks to has the highest number of crimes out of all the areas of Los Angeles. Now, as I mentioned during the importing of the data, we kind of just want the data, whatever it is, to get into the table. And we saw various errors with null values. Let's see if those affect the columns that we're particularly interested in. For example, crime code description, 369 rows where that is null. Now, that's 369 out of 1.8 million rows. So the rule of thumb is that if you have bad data in 5% of the whole data set, you're probably fine. You can probably just continue your analysis. Checking. You can continue your analysis, and bad missing data are probably not going to make a big change. It's not really invalidate your results. But let's just look. Sometimes you can find the correct data. So here's the 369 rows where crime code description is indeed null. Now, you notice there's something called MO codes. I don't know what that means. It looks like there's always a crime code, a 3-digit number. Now, again, if this were if I actually was hired by the city of Los Angeles or some agency, I might ask if the crime code correspond to a particular description. In fact, why don't we just see? We see 822. Okay, looks like, oh, okay. Okay, human. It looks like 822 has a crime code description: human trafficking, commercial sex acts. The thing is, though, without guidance from people, whoever, the people who create this data, which presumably is the police department, I'm not sure what 822 means. It sure looks like it means human trafficking, commercial sex acts. So I would love to know that for sure, and then I can just everywhere it's null, I can substitute this description: human trafficking, commercial sex acts. But again, this out of the whole file, this is a really small number of rows being affected by this. So I'm just not going to worry about it too much. Again, if I could, I would try to track down what these codes mean to see if I can, do the codes corresponding crime code description. I would try to track that down, but I wouldn't let it slow me down because it's a small number of rows out of the whole table. Let's see. Date occurred. I'm using that a lot. Is that null anywhere? No, none of them are null. Time occurred. Nope. Never null. Area name. I use that a lot in my analysis. Nope. None of them are null. Okay. So, and we could go through all the columns that I'm concerned with to see if anything's null. I might do let's do this. Another thing I might do is a distinct and what I want to do is order by and the reason I'm doing it this way, I'm getting just because obviously, many things that occur in the same date, and I'm going to scroll all the way down. And what I'm looking for is anything that looks weird or unusual. Sometimes when dates are incorrectly put in or missing, database systems in particular will put a different date. Sometimes you'll see the year will be 1900 or some weird date like that, which will be sometimes is a substitute date. Different systems handle missing data in their own way, so there'll be a date there, but it's incorrect. But I don't see that in this case, and I don't want to make a whole video where I just do that for every column, or at least every column that I'm concerned with. But just an idea is like after we import the data, we want to do some checks to look for bad or missing data. Now let's imagine we have been tasked with creating some way for other people to be able to access the data that we've imported. This could be people inside the IT organization or information technology, which is probably where we work. There could be other people who write reports or consume that data in various other ways within our department. And some organizations will have people outside the IT department who would also want access to that information for their own analysis. They might access the database directly, so they might want access to the table, or they might use a tool like Power BI, which can be hooked up to various data sources, and that gives them a powerful graphical tool to do their own analysis. And the thing is, though, we probably don't want them to touch the original table. I think we want to keep that exactly the way it is. We could always go back, just like we kept the file. We could keep it kind of the way it is if we need to investigate something or look at it further. But what we can do is create something called a view, which I'm going to show you here. I'm going to script it. What I've done is I've created this object called crime data underscore VW, so anyone using it understands they're using a view. If you're not familiar with the concept of a view, it's basically just what's called a select statement. And a select statement in SQL just presents data, it retrieves data and presents it to whoever is running the query. It doesn't change anything. It just presents data according to the criteria we have written. So you see I have the select query here on kind of more or less the right-hand side of the screen. And you see date reported, date occurred. These are just the same columns from the table. Then what I've done, part of the reason one creates a view is you can present data in a way that's easy and intuitive for other people to use. So you see here, I've used a function called date name on the column date occurred. And what I'm doing is I'm getting the actual name of the week for every single date. And then I'm using that, and I'm saying if it's Sunday, just give it a number 1. If it's Monday, give it number 2. Then date name, I get the name of the month. And then I get the year, and then I get the time occurred. And then, because people might want to do a time analysis over the time, the various times when crimes occur, I'm going to aggregate that, or give them a way to aggregate that, where if the time occurred is between 1 a.m. and 2 a.m., I'm going to have this column called time slot. I'm going to have a column called time slot, and if it's between 1 and 2, it'll say 0100 to 0200, because this is a 24-hour time clock. And I just go through all 24 hours. Then I include the area name. I include the crime code description, of course. I have location, and I'm just going to run this query for you so you can see what the data actually looks like. So name of incident, name of incident, that's the day. A number is attached to it. The month, the year, as I mentioned, time occurred, the time slot, area, the name of the crime. Incident coordinates. The file includes latitude and longitude for the actual crime. And, especially some tools like Power BI and Tableau and many others, they can use that to make an actual map, which could be very useful for some people. And you see I've also included the victim age and the victim sex. It's not always recorded, but that might be something people want to include in their analysis. And the idea, because the view will only show them what we've included in this select statement. So as you can see, we can hide or show data as we want. We can make it, we can present data in a consistent way. Okay, so I have taken the data in the view, and here's what I've been tasked to do is look at trends in intimate partner assaults by day and time for staffing purposes. My understanding of intimate partner assault, which again is assault against a spouse, a significant other, boyfriend, girlfriend, and so forth, as opposed to domestic violence can include that. Domestic violence can be assault against the elderly, against children, and so forth. So intimate partner violence is a subset of that. And let's say that people concerned with crime in the 77th Street area, they want to see numbers of incidents, of reported incidents throughout the week and throughout each day of the week, because they need to staff accordingly. These are very serious incidents in which not only the police but social workers might be needed. People might need to these emergency situations, emergency housing, because maybe somebody's in a dangerous situation and they really need to be taken out immediately. There might be children involved as well. And when such a thing happens, of course, you want everything ready to help the people involved. And incidents can happen any day of the week, any time of day. So here, since I've already created, let's go through the query here. I call this crime data underscore VW, so we know we're looking at the view. I'm specifying in the where clause, specifying the 77th Street area. And because there's more than one type of crime in intimate assault, intimate partner assault, I'm just going to do and just call it intimate partner assaults. I might add another column to this view. View column aggregating crime types. So I might create something, intimate partner assaults, that will include aggravated assault and simple assault. I'm just going to add this in there really quick. This was seen earlier in the video, but just to make it clear, you'll see aggravated assault and simple assault. So, but let's say we just, assault is assault. Let's say we want a report that tells us about intimate partner assault of any kind. So, as we saw, I had this up on the screen before. Oops, I did not include the order by. So you can see Sunday has the most number of assaults. Also, I'm looking at the year 2017 because that's, this is, hopefully if we were doing this in the real world, if it was a real job, we'd have more up-to-date information. Maybe we wouldn't. I don't know. And you see I'm including the day of incident number so that I can sort by it. So Sunday's at the top, and in fact, it has the most number of incidents. But we also want to know what time of day. So this right here tells us, okay, we probably want a lot of people available, resources available, people, the staffing schedule, a lot of people ready on Sunday. And so let's look at Sunday, where now I've included the time slot, and I'm also ordering by it. So 1 to 2, 2 to 3, and so forth. And it's interesting, we start off at 1, and this is 24-hour clocks. It's 1 a.m. to 2 a.m., 13, and then it goes to 18, and then it goes to 23. And it doesn't go, and then it seems to go down again. Just a quick look, if you kind of scan down, in fact, let's just look at Sunday. So you can see 2 to 4, that looks like a jump, and then 5 to 6 a.m., it goes down a bit. 1,500 to 1,600 hours, it goes up again. As we go into the night, we see some spikes. This is 2,000, 2,000 hours to 2,100 hours. That's 8 to 9 p.m. We see some spikes. So, I mean, we kind of might see the if we do this is Saturday and Sunday. We might see. That's kind of interesting. It is, Saturday into the evening. It looks like things. Well, it's funny. In 2,200, we have 6. And again, but what I was thinking is the numbers go up into Saturday evening and into early Sunday morning. And we might investigate some of these numbers. I mean, it was 18, then it was 6 and 15. We might look to see if anything, what's happening. We might, sort by time and date just to see if anything unusual is happening. This could be a data issue when you see a weird change like that. Something, all of a sudden something's way higher or way smaller. I mean, you see kind of a trend here. But also, we know this file, this data is pretty manually compiled. It's up to various, interpretation by various, various people who put it in. It's not one. This is what my understanding, that this file, it's not created by just one person. It's many people who are all putting in the data, and some people might be more careful than others. Do they record every single reported incident? And of course, this is especially the case something like crime. We're only looking at things that have been reported. That doesn't mean, if this row says in all of 2017, between 6 a.m. and 7 a.m. on Sundays, all year, and a whole year, only 4 reported domestic violence incidents. Maybe, it's in one area. So, it's not impossible. I think that's part of the issue, is you have to be open-minded to both problems with the data, and sometimes, data's weird. Data is supposed to reflect reality. Reality, it does what it does. I often find myself telling my employers and people who, I'm about to explain what employers are. The people who pay me to do data analysis, to say, okay, this reflects what the data says, the data I have. So if I look through and I said, yeah, these are all the records I have, are just, 3 3 incidents that meet all this criteria. 77th Street in the year 2017 on a Saturday between 7 and 8 a.m. That's what the data says. That's all you can do, is accurately reflect the data that you have. If there were incidents that were never reported or not recorded in the particular file we were given, that's just a different issue. You know, your responsibility as a data analyst is to accurately reflect the data that is provided to you. And you can ask questions to people. You can give those caveats that this is the data I have. I'm not saying that, you know, in the ultimate cosmic objective world sense, only 3 incidents occurred. Yeah, there could have been more. You know, in the real world, maybe there were more. Maybe there were a few. I mean, people, you know, these incidents are reported to the police. If something happened and it was not reported to the police, it can't be recorded here. How individual police officers or individuals record things. You know, we as data analysts don't control that either. Anyway, a lot of caveats and things to keep in mind when you're doing an analysis or explaining what you found. Like, you know, in the case I've imagined, we've been asked to do some analysis to help with staffing. We would show like, okay, here's your spikes. Sundays between 2 and 4, you historically have gotten a big spike. And then Sunday afternoons, you know, and then, you know, for a couple hours into it. And then, you know, early morning into the afternoon, maybe, you know, you expect a little fewer. That's the data we have. That's all we can show people.